Good morning. Today's bell ringer is on choosing classes, yesterday's assignment, Friday's assignment. So the class schedule for Introduction to Computers have 4 professors, Mr. Brown, Mrs. Black, Mr. Blue, and Miss Beige. As you can see, the classes are chosen at random. What is the probability that a student will get Mrs. Black or Miss Beige during 6th period? Okay, so the first thing you need to do is you need to count the number of classes total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 classes. Mrs. Black has a class 6 period, and Miss Beige has a class 6 period. So there are 2 possible options. 2 out of 16, which makes it, if I'm not mistaken, 2 out of 16 is 1/8, 12.5%. So good things. Season is almost over for tennis. I think we play on Tuesday and possibly another match after that. And we'll start our season in the spring, come in January. So anyway, please let me know if you have any good things to share with the class. I'd love to share that with the class here in one of these videos. All right, so in binomial probability and expected value is the name of the lesson, SAS 9. We have a bag with 3 cubes in it, 1 green and 2 white, and we then randomly pick a cube out of it. If you get a green cube, it's worth 2 points, and a white cube is only worth 1 point. What is the probability of selecting a green cube? And then what is the probability of selecting a white cube? And if one plays the game 15 times, how many times should one expect to select a green cube? Well, how about a white cube? How many points can one expect to have after 15 tries? So let's look at some of these answers. Probability of selecting a green cube. Well, okay, we have a bag with 3 cubes in it, 1 green and 2 white. You put your hand in there and randomly select 1. There's only 1 green, there's 2 white. You probably get 1 out of 3 tries green, as long as all of them are in there. What's the probability of selecting a white cube? Obviously, the remainder or the complement of 1/3, 2/3. There are 2 cubes in there that are white and only 1 that's green. Out of the 3, 2 are white. If you put your hand in there, you probably end up getting a green cube 2 times out of 3. So the green cube is worth 2 points and a white cube is 1 point. If one plays the game 15 times, how many times should one expect to select the green cube? Well, 5 times, 1/3 of the time. And a white cube, 10 times. So how many points? You get 2 points every green cube. There's 5 times, that's 10 points. And 1 point for every white cube, there's 10 times. That's another 10 points. So you should get 20 points. All right, let's move on. So National Baseball Batting Contest, rules of the game. You're pitched 5 fastballs, and you must hit into the fair zone to count. If you hit all 5 pitches fair, you win a large stuffed animal. 3 or 4 pitches fair, you win a small stuffed animal. 1 or 2 pitches fair, you win a bat-shaped pencil, and you miss all the pitches, you get no prize. The game costs $3 to play. That's a set of 5 fastballs for $3. All right, so let's look at this. This is what we call a tree diagram for binomial probability. There's only 2 options. It's like flipping a coin. In this case, you either hit or you miss. Now, in the first try, you either hit or you miss. So there's 2 tree diagrams for each one. There's a tree diagram if you start and hit the first hit successfully, and there's a tree diagram where if you miss the first hit or unsuccessful hitting the first hit. And then it splits. Second event, hit or miss. Third event, hit or miss. Fourth event, hit or miss. And then 5th event, hit or miss. As you can see, all the options are listed here at the end of the row. We can easily tell what our sample set is. Now, if you recall from the binomial numbering system we did, you probably know what 2 to the 5th is, and that could tell you what your sample set is. But 2 to the 5th is 2 times 2 times 2 times 2 times 2, which is 4, 8, 16, 32. So there are 32 options. 16 if you hit the first hit, or 16 if you missed the first hit. So let's move on. What are the possible outcomes? That's it right there on one page. All right, so what is the probability that someone will successfully hit all 5 pitches? Well, there's 32 possible. That's the sample set. And only 1 time can you hit all 5 pitches. If you miss 1, you just don't do it. So that answer is obviously 1 out of 32. How about 4 pitches? Let's move back. You've got to count all the ones that have 4 H's. 1, 2, 3. We could do this all day, but it's pretty simple if you think about it. 1 out of 32. There's probably 6 out of 32. No, 5 out of 32. I apologize. 3 pitches, believe it or not, it's the same, double that probability. You can hit 3 pitches 10 out of 32 times. You can hit 2 pitches 10 out of 32 times. 1 pitch 5 out of 32 times. And no pitches is 0 out of 32 times. Now, binomial probability does not take into the account of skill. So it's just based on equally likeliness, okay? So, all right, suppose someone tries the game 10 times. How many times should they hit the ball? We just multiply the probability by 10. 1 out of 32 times 10, or 0.3 wins per try. They're not expected to win in 10 tries. 5 out of 32 times 10 is 50 out of 32. That's 1.5, or 1 to 2 times. 3 tries, 10 out of 32, 100 out of 32, or 3 wins per try, or 3 wins in 10 tries. 2 is also 3 wins in 10 tries. 1 is 1 to 2 wins, and 0 times is probably not expected to win or lose. It should say lose, not expected to do that. I don't know why it says win at all, but you get the idea. If 160 people play each play the game once, how many large stuffed animals will be won? Okay, well, probability of someone successfully hitting 5 balls and winning a large stuffed animal is 1 out of 32, or about 3%. We multiply 1 out of 32 times 160, and we'll get 5. So only 5 are expected to win a large stuffed animal. Notice that we use the probability multiplied by the number of people that play the game. And that gives us the total we expect to win. We did this back when we did the probability of walking through the corn maze and getting a pumpkin. Remember that in the first lesson of this unit. All right, how many small stuffed animals will be won? Well, we have 2 probabilities whether they get a small, 3 or 4 hits. So probability of 3 is 0.31, probability of 4 is 0.16. Add those together, it's 5 out of 32 or 10 out of 30, 46.875%. 75 people should win a small stuffed animal. And believe it or not, 1 and 2 get the same answer, 75 people, because 2 is the same as 3 and 1 is the same as 4. So we get the same exact probability for this. About 75 people will win a bat-shaped pencil. And finally, how many people will not win anything? The same number of people that win a large stuffed animal will win nothing, because according to this equally likely binomial probability, they're only going to get 5 people that hit nothing. Of course, reminder that binomial probability does not have skill involved in its probability. So if a large stuffed animal cost the game organizer $6 and a small stuffed animal cost $1 and a pencil cost 25 cents, how much profit do you expect the group to make from 160 players? Now remember, profit is the difference between revenue and expenses. Now, if expenses is larger than revenue, it's a loss. But if revenue is larger than expenses, it's a profit. So let's look at this. We got to look at each one individually. All right? So if 160 players play, we already know 5 large stuffed animals will be given away. That cost us $30. 75 small stuffed animals, which cost us $1 a piece, that cost us $75. And then 75 pencils are given away at $0.25 a piece, and that cost us, I'm not sure, but the total of expenses for the game, for the prizes, is $123.75. So the profit for the game, we're going to make $480 for $3 times 160. So that's our revenue. $123.75 is our expenses. We find the difference between those two, and we find a profit of $356.25. Now, this is really important to understand, because this is going to help you. This slide specifically is going to help you do your project, because you need to understand how this works. The only difference in the project in this particular example here is that you have to add in the cost to build your prototype, or the cost to build a game, so that you can be persuasive to whoever's trying to buy this game from you, or the potential buyers. So for the game described, you found probabilities for hitting 5, 4, 3, 2, and 1, or 0 pitches. Suppose the game has changed and you pitched various number of pitches. Find the probability of each outcome and look for a pattern of numbers. So 1 pitch, 1 hit or 0 hits. Half will hit it, half will not. That's based on equal likelihood, right? How about 2 pitches? There's 3 possibilities. Hit 2 hits, hit 1 hit, or hit no hits. Half of them will hit 1 hit, because either you miss the first one, or you hit the second one, or you hit the first one, you miss the second one. If you hit both hits, you have to hit both. There's only one probability of that happening. And then if you either miss both of them or you hit one or you hit two. So that's 1 out of 4. There's only 4 opportunities. Hit 2, hit 1, either the first one or the second one, or you hit neither one. So 1/4 of them will hit 2 hits, 1/4 of them will hit 0 hits, and half of them will hit 1 hit. We can do this for 3 hits. Does the same thing. 1 out of 8. And then out of 4 hits, 1 out of 16. You notice something to the denominator. If you remember when we did the binomial numbering system, that 2 moved up by 2 in that numbering system. Well, we do the same thing in binomial probability. Notice that the sample set is in the denominator. Now we're going to simplify some of these numbers. That's 4 out of 16, and that's 6 out of 16. Notice the probability is higher for the middle numbers. So consider the geometric arrangement known as Pascal's triangle below. Decide how the values in a triangle are generated and compare the values you found for the probabilities in the previous values to the values in the triangle. So you've got 1 in the first row, 1 and 1 in the second row, 1, 2, 1 in the third row, 1, 3, 3, 1 in the fourth row. Well, let's start over. 1 in the 0 row. I got to tell it this way because if I don't, you don't understand. You won't understand exactly what's going on, and I don't want to confuse anyone. The first row would be actually this row. Either you hit or you miss. Think of it in terms of that hitting a baseball. Pitch 3 pitches. Either you miss. Oh, no, hitting 2 pitches. Yeah, 2 pitches. That's 1 pitch. Either you hit or you miss. 2 pitches. Either you miss both of them, you hit the first or you hit the second one. That's 2 options. So you hit 1 or you hit both of them, and that's 1. This is 3 pitches, 1, 3, 3, 1. 4 pitches, 1, 4, 6, 4, 1. And then 5 pitches, 1, 5, 10, 10, 5, 1. Now, if you look at it, how is it generated? Notice that 1s cascade down the sides. But look what's in the center. If you add these numbers together, you get this number here, 2. You add these numbers together, you get this number 3, and you add these numbers together, you get this number 3. Same thing here. You add the numbers above it on both sides, you're going to get that number. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and 1 stays on the outside. So I bet you can imagine what the next row would look like just by that information. But sum is 1, outcome for no pitches. Sum is 2, outcome for 1 pitch. 4, 8, 16, 32. These are the probability denominators. You see that specific information. I just discussed it a second ago. All right, only 1 outcome for 0 pitches a miss. You can't hit a pitch that's not pitched, right? So if you have no pitches, you have 1 outcome. You're going to miss it. 2 outcomes for 1 pitch, a hit or a miss. 4 outcomes for 2 pitches. 1, 2 hits, 2, 1 hits, and 1, 0 hit. 8 outcomes for 3 pitches, and so on, all the way down to the 32 outcomes in the last row. Each number in the row are the probability numerators, and each sum of each row is the denominators. So if you sum these numbers up, they should add to 32, and they do. So if you had to successfully hit 6 of 6 pitches to win the large stuffed animal, what is the probability of winning a large stuffed animal? Use Pascal's triangle in your solution. So if this is 0, that's 1, 2, 3, 4, 5. This is 6 hits. We would sum these numbers up to get our denominator, and either this one or this one, that's going to be 0, 1, 2, 3, 4, 5, 6. That's going to be 1 out of whatever the sum of this is, and I believe it's 64. So you have 1 in 64 chance of hitting all 6 pitches to win a large stuffed animal, and that's true. With our 64 outcomes, 1 out of 64, or 1.56%. Okay, so I'm going to launch you with this. I like putting memes as my launch. I heard you like Pascal's triangle, so we put triangular numbers in a triangle of numbers that contains other triangles of numbers. Yeah, that's exactly true. So anyway, there is a lesson that's going to be in the Google Classroom. Be sure to check that out. Get it done as soon as possible. Remember, it goes missing. It gets marked in the grade book as a 0. And on Wednesdays, they call your parents and let them know that you have got missing assignments. Anyway, as usual, have a great day. Be blessed and be a blessing.